basically similar figures can be enlarged or reduced in such a way that they can be superimposed right directly on top of each other. Okay, so they may or may not be oriented in the same direction, okay, but the two properties that are true for all similar figures and most of all the similar triangles is their corresponding angles are equal and their corresponding sides, they're not necessarily going to be equal, but they are proportional. And if you remember from algebra, that means they have the same ratio. Okay, so if we look at these measures for triangle ABC and EFD down here, what we see is all of their corresponding angles are equal to each other. So that's one of the properties of similar figures. And then the other properties, all of their sides have ratios that are exactly the same. So the ratio of AC to DE is 3 to 2. Ratio of BA to EF, also 3 to 2, or 1.5. Ratio of CB to FD, also 3 to 2. If all of their sides are proportional and all of their corresponding angles are equal, then you know that these two triangles are similar to each other. Okay, so when you write a similarity statement, it's just like writing a congruent statement. You take your triangle, ABC, any arbitrary order. But when you identify your similar triangle, you have to match the corresponding parts. Okay, so A corresponds with E, point B corresponds with F, and C corresponds with D. So this would be your final similarity statement. Okay, and then if we were just basing it off of the statement itself, this similarity statement identifies all these relationships. So this would tell us that angles A and E were equal. It would tell us angle B and F were equal. And it would tell us angle C and D were equal. It would also tell us that their corresponding sides are proportional. So the ratio of AB over its corresponding parts, EF, is going to be the same as every corresponding pair. So BC over FD, and that's the same ratio of AC over ED. Okay, so all of these relationships will hold true based on the similarity statement.